Okay, so we are getting into the more advanced or hacky stuff. We're still going through the basics of web performance that you should already be applying in your websites. But anyway, talking about JavaScript, it's something that I mentioned before. It's a more general advice. Release the main thread as soon as possible. What's the main thread? The only thread where you're executing code by default. So you shouldn't start executing code. You shouldn't take more than 15 milliseconds of the thread. Actually, that's known as a long task. If you have some JavaScript code that is taking more than 15 milliseconds, and of course that depends on the CPU, but if it's taking more than 15 milliseconds, it's converting into a long task. And that long task is probably pushing the rendering of the next frames. So you have like a kind of a clunky user interface if that happens. Embrace responsive images. Responsive images means that you are providing to the user the image that it needs. Not just a large image that then you, with CSS, resize, things like that. And we will get into that later. Embrace SVG for icons, for logos. Every time it's a vector-based image, it will be much better to send SVG. On 98% of the situations. There are some cases, and remember, don't trust me. Try it, test that. Make two versions, compare the versions, see the waterfall charts, see how the web vitals are doing on each case, and then make a decision. Compress images, define placeholder size. You know, placeholder size is use CSS or HTML to define the width and the height of the image placeholder. If you don't do that, and I think that's one of the problems we have in our website, we will have content layout shift, because the browser will not know the size of the image before actually downloading the image. So you need to download the image, decode the image to actually know, oh, that image is 100 by 50. And then it needs to lay out the rest of the elements around. Okay, makes sense? And compress images is using tools that will compress your JPEG files, your PNG files, to remove unnecessary data. I will show you some tools in a minute. Careful with web fonts. We are using web fonts. What's the problem with web fonts? Web fonts are really nice. They can be really nice in your screen. But actually text, by default, is non-blocking. When you have text in your HTML, your text will appear, unless you use web fonts. When you use web fonts, and it depends how you're using web fonts, by default, you are converting something that is non-blocking into something that is blocking. Because now you won't see text until the font is downloaded and parsed. There are ways to solve that problem or to deal with that, okay? But for now, let's say, be careful. So those were just basic ideas on web optimization. Do you have any questions on any of those?
What could I Google then to figure out how to circumvent that? What would be the best? Just so you don't have to go into it yourself, just for me personally.
About images or about which part?
How to circumvent the web fonts so that...
Web fonts, okay. Give me a couple of slides,
okay.
and I think I will answer that part.
Regarding JavaScript imports, what happens if you use both defer and async?
It doesn't work. So it's one or the other. So actually, the browser will pick one of both. So it's even if it's not a technical restriction from an HTML syntax point of view, you cannot set both at the same time. So it will just pick one. So don't do that. Don't set both at the same time. Well, hacking performance. So far, those were the basic ideas. Some are very general, but now we will get deeper into how to hack performance, how to count every millisecond for us. Okay, there will be a couple of things that we will see that are really hacky, and they have a really cost of implementation. So it will worth the effort on some situations only. There are other techniques that are more okay for most websites and web apps. Okay, that's the warning. We're going to start hacking the first load. That is when you get into the website for the first time. So first, avoid more than one round trip. This is the first one is really hacky. Okay, you have the warning. So avoid more than one round trip. What is this? It had to do with TCP, how TCP works. Remember I mentioned before that TCP, the low-level protocol that HTTP is using, TCP will split our response in several packets. Okay, remember that? And each packet will go through the network, and sometimes TCP will need to send another one again because it gets lost and things like that. But there is a hack that says, what if we try to send the response in only one packet? So the HTTP response, the first one. What's the first one? The HTML. The most important one, because if the browser doesn't have the HTML, it can't move the loading process. Okay? So what if we send only one packet? For that, we need to get into the TCP protocol and learn about something known as slow start. Because what's the size of a packet? We don't know. In fact, it's dynamic. But we know about the first one. The first answer will start slowly. And that means that there is something known as initial congestion window. It doesn't matter. It's too technical. But anyway, on Linux or Linux-based servers, if you don't touch that setup, it's 14.6 KIV. 14.6 KIV. And the next question is, KIV? What's that? Well, let me ask you a question. How many bytes in a kilobyte?
1,000?
1,000?
You said 1,024.
1,024? Which one? 1,000? 1,034? It's a very basic question. And you are giving me weird faces right now.
Well, the metric prefix for kilo is 1,000, but 2 to the 10th is almost 1,000.
So let's try to answer the question. Well, 1 kV is 1024. That's what most people will answer. Actually, when you do a survey, I'm not saying this yet as the statement, the final statement. I'm saying that typically a survey between technical people, even developers, will give you 80% will respond 1024, so 1024. But actually, that's wrong. I know that a lot of you, mostly here on the video, are trying to kill me at this point, but bear with me for a second. Actually, it's 1,000 because the kilo prefix is 1,000, and it's not just me, right? So you can go and ask Siri. That is asking actually Wolfram Alpha, that is a scientific website. You can ask Google, how many bytes in a kilobyte. You can ask ChatGPT, okay, if you want. I don't have the ChatGPT thing. You can ask Wikipedia. It's 1,000. Yeah, we were wrong. There is a history of what happened, blah, 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 the binary previous to. Actually, that was set legally and formally within standards in 1998. Okay, so long time ago, 25 years ago, and we are still not sure about what kilobytes mean. Well, anyway, a KV byte, not kilobyte, KV byte is the one that still exists for 1024. That's KIV. Okay, so KIV means KV bytes. So I'm saying this because when we're talking about bytes and milliseconds, everything counts. So this is a KV byte, Men in Black, or maybe bytes, GB bytes. So those are the ones that are using powers of 2, and then the other ones, legally, technically, are actually using 1,000. The main responsible of the confusion today is Windows, because Windows is not following this. Linux and macOS based on Unix is using this one. So the idea is it's KIV or it's KV 1000, but Windows is using KV for 1024. So it's not following the spec, the standards, the industry. Anyway, going back, we were saying that one KIV, one KV byte, is 1024 bytes. So going back to this idea, we were saying that on Linux, 14.6 KV bytes is the initial congestion window, which means if you can fit within 14.6 KB bytes the HTML, it won't be split into more than one TCP packet. So it will arrive to the client as soon as possible, because we don't need to send more than one packet, wait for them, reorder them, see if it's there or not, blah, blah, blah. But you're thinking, 14, yeah, it's not so good. But remember that it's HTML, and we are shipping the HTML. So that's roughly 70K of HTML, which sounds better than 14. This is very hacky, okay? I know it's very hacky. And also, for this, typically, and I'm going to take something from my bag. I shouldn't be doing this live anyway. Not a big deal anyway. So when we are doing with performance, typically we say that we have something known as above the fold, ATF, and something known as below the fold, BTF. Some people typically ask the fold, are we talking about foldables? Well, actually, these terms are coming from printed newspapers. Okay, so the idea when you are paying for an ad in a newspaper, you have above the fold, this is the fold, okay? Above the fold or below the fold. Below the fold is cheaper than putting an ad above the fold. Okay, so we are using those terms here as well on the web. Of course, we don't have a fold, even if you have a foldable device. We are talking about the scroll actually. So above the fold is the first scroll. Okay, and everything that goes below what you see without scrolling, that's below the fold. So when we're talking about 14.6 KB, maybe we don't need to serve the whole HTML. We can serve just above the fold, because what we need is to achieve users' perception of performance. That is, for example, largest contentful pane. Remember? So if we achieve that, then maybe we can fit in 70K of HTML the code necessary to render the above the fold. So what can you add that there? If you can embed CSS and JavaScript, much better. And if there is a space, you can even embed the logo in SVG. Everything that you can fit within 70K will worth the effort. Who is going to use this technique? Today, this technique is being used a lot on some special regions of the world. Africa, some countries in South Asia, where they have a really performance penalty. For example, they have 30% of users on 2G. And we have a really big latency problem there. So we don't want to have a lot of TCP packets. Okay, makes sense? In fact, I'm not saying that they're using this technique today. They used to use that. Google.com, the mobile version, used to have some of this technique in action. So if I enable the mobile user agent, so I simulate Galaxy, the mobile version, let's see now, because I don't know what's going on, but yes, they have CSS inline. So it's not an external file. Can you see that CSS there? And in fact, let's see the source code, like so. We have JavaScript. That's JavaScript. Let me increase the font size. JavaScript. We have, that's more JavaScript. We usually have CSS somewhere. And sometimes, I'm not sure right now if I'm going to find it, yeah. I have sometimes images. Everything embedded in the HTML. Why? To avoid more TCP rounds, to avoid more HTTP requests. So then the content can be as fast as possible, really fast. It's really hacky. Yes, it is.
So that just all become like that in that file during whatever your build is for whatever.
Yeah, you can have a build process, your development process. It can be server-side rendering as well. That is merging all these files into just one.
Kind of like Tailwind, I guess.
Yeah, but if you can fit this in 14.6 compressed, then everything will fit in one TCP packet. Okay, hacky, yeah, but yeah, we're hacking web performance, right? This one is interesting. You should avoid HTTP to HTTPS redirect. Fortunately for us, this is being replaced on many browsers. So here's the deal. What happens when you type a URL? You see an ad on TV, okay, buyme.com. So you go and type buyme.com. You don't type https:// you just type buyme.com. So is it trying HTTP or HTTPS? Typically, originally it was HTTP, and then the server was saying, no, we have a redirect to HTTPS. So for that, for a long time, browsers were using something known as HSTS, HTTP Strict Transport Security, which is just a header that you can add in your website, and you can opt in within that URL. Let me explain what that is. When you go to that website, HSTS preload, and you have a website, you can add a URL. Let's add, I don't know, NewYorkTimes.com. Let's check, and it says, no, it's not supporting the standard, so it's not supporting. Can it? Maybe. CNN? No. You can see there are a lot of websites that are still not using this technique. Google.com? No. You say, oh, what's going on? Well, what's this? It's saying that you don't have the header. And what's the deal with this? It's just this header that you need to add when you are responding with your HTML. That header will say to the browser, hey browser, you know what? Here, in this website, we always support HTTPS on every URL. So it's safe from now on to always go to HTTPS first. That's HSTS. So in that case, when you're using typing your URL, it will go directly to HTTPS. It's avoiding one redirect. Does it make sense? And this, wherever you, if you log in your website here, White House, FBI, I don't want to try FBI. That's green. So White House, it's actually preloaded. That means if you try whitehouse.gov in your browsers without the protocol, it will go directly to HTTPS.
How many milliseconds does that save?
That's going to save one TCP connection, and it can be around 150 to 100 milliseconds, which is, again, 5% of our budget, so it's not bad. So again, what do you need to do? You need to set up this in your server. It's a header. And of course, for that, every URL in your domain must be served with HTTPS. And today, there are a couple of domains that you can buy, such as .app. Have you seen the .app app? .app or .web? And those domains are HSTS by default. Actually, you cannot serve HTTP over those domains. You cannot. It's not going to work.
Do you need a certificate or anything like that? So
You need the same certificate as HTTPS. So you don't need a special certificate. You need to send the header and then add your domain in this website, and you will get into a whitelist, that's the name, an allowed list that then you can remove if you want. Several browsers, Safari, Firefox, and Chrome, are using the list from this website. It's kind of a standard. Anyway, some browsers today are changing the algorithm, and they're trying HTTPS first. And only if it's returning an error, it's going to HTTP. Fortunately, they're changing the algorithm. Okay. Now, LCP. We mentioned that LCP, large content of paint, is the most important metric for our website, right? So it's the largest part of content that the user's brain will parse. So we need to hack that as much as possible. One thing that we can do is preload. What is this? It will help the browser discover resources that are obscure in the document. Let's try to understand what that is first. Going back to our solution, that remember you can try on your own device, let's see our content here. Let me get out of this front-end museum. I think that image is our largest contentful pane. Okay, so if you look at the image is gallery ancient Greece.png. Okay, that's the name of the file. Okay, when we see here, it's not in the HTML. So we know it's important. Actually, it's the most important part for performance. We want that image as soon as possible, right? We all agree on that, right? So if we go to the network tab, I'm going to move it. Where is that JPEG file here? Let's see. That's a script, that's a logo, that's a gradient, that's a font, the JSON, ancient Greece. Here it is. So when we look at the diagram, we wasted all this time to actually download the file earlier. And if I see the details of that, we can see that it was queued at 5:16 seconds. What is that? That is, at that moment, it was discovered. When it's queued is when it's discovered. So for 5 seconds, the browser didn't know about that PNG file. That, by the way, shouldn't be a PNG, but that's for another slide. So what's going on? So we need to analyze what's going on. Why is that the browser is not downloading that PNG file faster? Well, the problem is that on how this website is being created, that there are a lot of websites out there like this. There is a script file that we can see. The script file, it's registering an event on the load event. Okay? That we already mentioned that. Is it a good idea? No. The load event will happen after all the images and everything is downloaded. So we can start helping this. We can change onload for on-DOM content loaded or use add event listener. It's DOM content loaded. So I'm going to call load on DOM content loaded. This will save a couple of milliseconds, if not seconds, to start executing this code. Then this code is downloading a JSON file. And based on that JSON file, it's rendering articles on the screen. That's why the image is being discovered late. So the browser needs to execute that JavaScript. So it was waiting for the load, executing the JavaScript, going and fetching the JSON, then parsing the JSON, then looping through the objects that we have there and creating HTML. And at one point the browser says, oh, there is an image, I need to go and find. And we lost not 5 seconds, but probably 4. And we could download that PNG file earlier. So we can, of course, change this. So we have a big problem here. The big problem is that this was a bad idea from the first time. Okay, so rendering content on the screen based on JavaScript that needs to download a JSON file, it's a bad idea from scratch. But let's say that for now we cannot change that. What we can do, what else we can do? We can use preload. So we can help the discovery of that file with preload. Preload is a link element that we can set typically in the head of our HTML. And in this case, we're going to help that queue of discovered elements. We are going to say, hey, browser, we will need that PNG file. You don't know yet that we will need that, but believe me, I'm the author. I know that you will need that later. So for that, then, we go to the HTML and add that link. It's link rel preload. The name is going to be images / no, images, no, I'm sorry, gallery / it was ancient Greece. And it's mandatory to set as. So I'm going to download this as an image, as a style sheet, as a script. So there is a list in the spec of values for that as. So in this case, we are moving within the timeline, within our waterfall chart, the discovery of that element. We will still have the problem that the browser will not know what to do with it for a while before executing the JavaScript, but at least when that moment is there, the image is there waiting for the browser. So it will be rendered faster. Does it make sense?
Sorry, so that link with the preload, that line there doesn't actually, like, won't actually display the image.
No,
it just sort of
exactly.
prepares it for when it's, and so when is it actually being asked to be rendered? It's within that script?
We didn't change that. We didn't change that part. In this case, it's the script. The only thing that we changed is we changed the event. So now instead of being the load event, we improved that a little bit on DOM content loaded. And within this event is fetching the data.json. And for each element that we have here, we are creating this little HTML that we are injecting. And that HTML has an image
Yeah, and so at that line there, in that loop there,
here. And that line 13, actually not even in the line 13, when we release the thread of that event listener, the browser will say, okay, let's see what has just passed. And it will say, oh, we have more HTML to render. It will parse that new HTML, it will update the DOM, and it will realize that there is a new image to render, and it will fire the queue. Not this one. I think, yeah, this one. It will need a resource. And it will check the cache. It's in the cache. So actually, it's a cache hit, and it's not expire. So you will use the file from the cache. It works like that. That's the idea. Okay. So when you need it, when the browser needs that file, it's there. Am I in the final version? No, I'm applying small updates, okay, to this code to make it even better. Okay, I'm not saying that it's fine, but it's getting better on each iteration. So how do I know that now it's better? Look at the image now. Let's go like this. Ancient Greece now, it's being downloaded in parallel with the CSS immediately. I'm not saying it's being rendered there after downloading the file, because I'm not saying that because it's not happening, but at least it's being downloaded as soon as possible, and then when the JavaScript is executed, this is the JavaScript file, and then the data.json file is here. So after this is parsed, at that point it realized, oh yeah, the image, but the image was already downloaded. So we use data preload, we use link rel preload to help that discovery process. And we typically use that for elements that are hidden or obscure in the HTML. So we don't typically do that with logo PNG. There is no need for that, because logo PNG is already in the HTML defined. So the discovery will happen anyway pretty soon.
What would happen if you just put that on every single
one? Well, if you add that on every single element, what happens is that when everything is important, nothing is important. So it's like not doing it, actually. The advantage of using these APIs is that now you have control to help the browser prioritize what you need to make it better. That by default, the browser doesn't know exactly what will happen with that website, with that rendering process. But we know, because we are the authors, so we know where we are trying to achieve here. And then based with that, we want to improve LCP. And we know that that image is in the LCP, then we apply that. So this is one example for preload. In our code, what other example do we have for preload? Fonts. Let me get some water.
like lazy loading?
Not for lazy load. So how fonts work? This is a CSS file. Okay, so this link is not downloading the font. This link is downloading the CSS file that is pointing to the font. Does it make sense? If the font is important for LCP, that I'm not saying is the case for every case, we should check which of these fonts are the ones I need. How do I check that? Well, maybe I can go to the network layer and see which font file is being downloaded. It's this one. So if I believe that that font is mandatory for the LCP, don't do this for every font. Only for the one that you know it will improve or it may improve your web vitals. You can go, copy the URL, and add the rel preload for the font file itself. So rel preload href that long list long URL as font. So in this case, that URL, the actual, it's a WOF file. That WOF file was obscure for the HTML. The HTML didn't know about that. The HTML needs to first download the HTML, the CSS, parse that CSS to actually know that WOF file. Well, we can preload it. That's another use case. But again, don't add preload on anything, or don't add preload with elements that are already visible in the HTML. So if you see the reference in the HTML, you don't need to preload, because it will be in the queue anyway. Preload is being used to actually help the discovery of that file. Okay, makes sense? By the way, if you're wondering why, if you try this Frontend Museum website, every time you reload, it's different, right? The performance, sometimes it's better, sometimes it's worse. It's a little bit inconsistent. Okay, why is that? I'm not sure if you were curious enough to go and see what's going on. The server is actually making a pause. This is a middleware in Express.js that is making a random delay, let's say a fake delay, on every request from 100 to 1600 milliseconds. So every request, every image, every CSS will have a delay. It's like the server is, or the latency. So I'm faking this so we can see better in action how small changes in the front end can lead to much better web vitals. Okay? Any question on preload?
Maybe you're going to get to this, but is preload and
Prefetch?
is preload similar to prefetch, and can the two be used interchangeably?
No, prefetch, we're going to cover prefetch in a couple of slides, is for a different use case. So, so it's not the same. In fact, prefetch in history, I'm not sure which prefetch are you talking about actually, but we used to have several kind of prefetches. Today we have DNS prefetch, for example, that we will see in a minute, but it's for a different use case. Typically, it's not the same use case. Preloading can also be set through HTTP headers. So instead of adding it in the HTML, you can even went a little bit like lower in the timeline and add that as an HTTP header in the response. So you are the browser, you're asking me for the HTML, and I'm responding. I'm saying, hey, go and download that CSS. Here you have the HTML. So then your browser will know that that CSS or that WOF file will be needed even before starting rendering the HTML. Does that make sense? So then with the headers, the browser will know that there is a need to preload some other resources. Fetch priority. Now, what if we make a change in our code? What if we finally convince our manager that we have to change our architecture? So this idea that the HTML needs to wait for a JSON, first for a JavaScript, to download a JSON, to parse the JSON, to actually know what's in the first, at least in the LCP. So we convince the manager that that's a bad idea. So the best idea, which is making a server-side render. Somehow, Next.js or something like that. Just a few minutes ago, I saw a tweet from Guillermo Rauch. He's we can even look at that tweet so you can see it. I'm not lying. Twitter. It's Rauch G, I think. Yeah. So from some minutes ago, he's the CEO of Vercel. He's the creator of Next.js and Vercel. And he tweeted about, where is it? Should be here. This one. The biggest product of the past 20 years, ChatGPT, is a website built with Next.js, which is saying that the biggest, the largest, like ChatGPT is using Next.js. And what's Next.js? It's a library to use React components, but server-side, not client-side. And typically that leads to performance. Okay, and so the idea here is that, well, ChatGPT is so fast because it's based on Next.js. So it's not client-based JavaScript, it's server-based JavaScript. So if you like React, it's okay, but maybe making those React components being rendered only client-side, it's not really the best of the ideas.
Just one thing I didn't really fully understand with that was because like with React it would be just re-rendering a specific like DOM section, but then with Next.js is like re-rendering the whole page, right?
Not really. So Next.js is not re-rendering all the time the same page. It's smart enough to just render what changed. So it's a mix. It's a hybrid technology.
Okay.
So even it has several names. So sometimes it's not just like classic server side with PHP or ASP Classic. So it starts on the server, but then it can continue client side. Does it make sense?
Yeah. That makes
So it's not completely server side. So it's a mix. The idea of the first rendering should be server side. It's actually the best idea for performance. Why? Because if not, we have the problem here. Our content, we just see a logo. What do we have in our HTML? A logo, that's all. And an empty main element. For rendering the content, we need to wait for JavaScript to download, execute it, and in our case, that JavaScript was also going to a JSON file. So then we have a sequence of downloads that cannot be done in parallel. Yeah, I could add a preload also to the JSON. So then we also download the JSON, so when JavaScript needs the JSON, it's already there. Yeah, but the best idea here is that maybe what we need is, at least for the first item, I can just, for now I can do this really quickly, I can take the article, right-click, and I can copy this as HTML. Copy the element or the outer HTML. So, and somehow, let's say server-side with a build process, we just paste the article. So if we do that, then this is going to be as fast as possible because, yeah, we don't need to wait for JavaScript. We don't need to wait for the JSON to appear. Now we will have that twice. We should skip it in the JSON. But and now look at this. Now that we have the image here, maybe the preload is not necessary because we don't need to actually discover it. It's going to be discovered automatically. So I can get rid of that now. However, wait a minute. So if I run this now, it looks better. Yeah, I have two Asian Greek. I should remove the second one. But I'm not sure if you realize that, yeah, it's getting kind of a little better. Okay, the LCP. It's getting a little better. But when we go back to the network and try to find the image here, the Asian Greece, that one, now it's not, actually it has two for some reason. This is the other one. Okay. Oh, I think that was the preload because I didn't reload. This is the one from the script. It's still here. So we still have like a gap there. So what is that? Remember that when I started showing you this, I right-click on the columns. And from here, there are a lot of columns that we can add. And I can add priority. With priority, you can see the priority of some resources based on the type. This priority was set by the browser. And we have highest, high, low. For example, the script.js is low. And now when you think about this, no, I don't think it's low. So I'm the author of the website. I think it's important because that's the one that is rendering the content. So no, why low? Well, other images are also having a low priority. Well, there is a new spec now, fetch priority, where you can override the default priority. And you can use it on rel preload and also directly over images. So for example, that means that for our LCP image, the one that we know that is the most important one, I can change the fetch priority. So I can go to this IMG, and I can say fetch priority high. So now I don't rely on browser's algorithm. I say, no, browser, this is high priority. The next question is, what happens if I add high priority on every resource? Well, again, if everything is important, nothing is important. So don't do that. Be smart, and pick the ones that you prefer, that you need. Does it make sense? And this will improve a lot LCP, mostly when it's image based. Remember, 75% of LCPs are actually image based, not text based. Any question on fetch priority? Does it make sense? And for example, I could change also fetch priority on the preload. If I feel that that font is important, I can also change the fetch priority and say high. And if I see that my browser is setting high on something that I don't think is important, for example, Aristotle, I can add low. So I can change the default priority. So I can help the browser make a right decision to improve the user experience based on my content, on how my content looks like. Does it make sense? Have in mind that fetch priority was called priority hints before. In fact, all my previous workshops and talks on web performance, I call that priority hints. So now it's called fetch priority. So when the standard specs discuss the idea, they change the name, and also they change the name of the property. Okay. Before it was called importance. Importance equals low or high. Well, now it's fetch priority. Okay, does it make sense? Cool. And this one is also really cool. It's more, I don't want to say experimental because it's not experimental, but it needs some work on your side. Let's say that. It's called HTTP early hints. This is not so simple as adding a link tag. So that's what I mean. It's actually pretty cool. Let's say it's common if you're doing server-side rendering. Let's say that case, you're doing server-side rendering. If you're doing server-side rendering, the server receives the request, and then it takes some time to execute that on the server, on the cloud, right? And then it responds with the HTML. That's how it works. With early hints, instead of responding with HTTP 200, the server can respond with 103. It's called early hints. And after the code, it can respond with preload declarations. So let me explain what that means. And you are the browser, you're asking me for HTML, so you contact me, and you say, oh, you want the HTML? I need to go and do a lot of stuff before. But before doing that, I will respond you with 103. And it says, okay, in the meantime, why don't you go and grab this CSS, this font, and that image? Okay, wait for me. Then I go, I do my stuff, and when I have my HTML over the same connection that is still waiting, now I add an HTTP 200 and the file. So early hints can let the browser download or know about other resources around 200, 250 milliseconds earlier. Does it make sense? So what happens if the browser, so this is the diagram. So normally, this is how, at the left, you will see how that works. We have the client and we have the server. The client asks for index.html, then it took some time to think, and then it answered with 200. Okay? And then the browser realized, oh, you need a CSS, I need a CSS, so it requests the CSS. With early hints, I ask for index.html, and the server immediately, without waiting, responds with 103 and the hints, like you will need a CSS, so go and request that in the meantime. So while the server is working on the final response, in the meantime, we can take advantage of the bandwidth to download the CSS. and over the same connection, then we get the file. Does it make sense? One of the good things about this is that it's backward compatible. If a browser does not support ClientHints 103, it will ignore it. So when the browser Safari or a browser that is not supporting this reads 103, it says, what? I don't know. Okay, let's wait. And it continue wait. It will wait for the 200. Yeah, you won't have the early hints, but the website will work anyway. Does it make sense? Do you have any question on early hints? You have a nice article on web.dev about early hints, how to implement that, how to do that with Apache or with Nginx. And today, if you're using Cloudflare or other proxy-based providers, you can enable early hints, and they will do that for you. So you set up the cloud to enable early hints. You specify which early hints you want to send to the browser, and it will do that for you. So it's difficult to test this with our example. We have to make a lot of work in Node.js. But actually, what will happen is that we will move here. For example, if we set early hints, the styles.css, the background CSS, we can start these two downloads can actually start here, around here. So we can pull the diagram, right? You can pull a little bit. And remember, that also is pulling the vertical bars, our milestones, our web vitals. Okay, cool. We already said that, but if a browser doesn't yet support early hints, nothing will happen. The browser will simply ignore it and wait for 200. It's the same HTTP connection, so over the same connection is like a partial response. It's possible to do partial responses over the same HTTP response. Okay? Cool. Another section is hacking data transfer. Well, first, HTTP 3. We have already mentioned this, but try to enable HTTP 3. We already mentioned it's a transport protocol over UDP that will reduce latency and connection messages. It's the same HTTP 2, so no different API. It's not going to add you a lot of overhead. So this is roughly how it works. By the way, it says Quick because Quick was the, let's say, the draft name of HTTP 3, but it's HTTP 3. So on a normal TCP plus TLS, so that's HTTPS, you have all these handshakes. You need to go, back, go, back, go, back, go. And of course, that has a latency. With HTTP 3, you just go. Okay, so it's called, there is a, for the second communication, there is a zero latency. That's the name of the zero RTT, round trip time. So on Google, it improved 3%. On YouTube, it has reduced the buffering of video by 30%. And Facebook is using a similar protocol on their native app, and it has improved 2% performance just by enabling something in your server or using tools such as Cloudflare that will do that for you. I'm saying all the time Cloudflare because it's the one that has a free tier that you can apply on free websites pretty quickly. If not, there are a lot of other providers that you have to pay for. Also, Cloudflare has a premium account, but Cloudflare is used a lot on many websites because it has a free tier. And according to Google, 75% of requests that are happening on the web can be optimized if HTTP 3 is enabled.
You know, so the difference between what is it, UDP and TCP is with UDP, it allows you to sort of, you don't retry any failed packets. What are the, I guess I don't quite understand, what's the, sounds like that would be a bad thing with web traffic.
I know, yeah. It sounds like that. For video, for live video, it sounds okay because, okay, if you have lost some frames, well, okay, yeah. Let's move on. With data, you want all the data. So it feels dangerous, like you're losing packets. But actually, HTTP 3 is using UDP and adding a control thin layer on top of that. So HTTP 3 is guaranteed that the packets will be received and they will retry packets if they are lost. But it's a thin layer written from scratch in the latest 5 years, 3 years actually. It's not the original TCP protocol that was written like 30 something years ago. So they created that thin layer, that control layer, specifically targeting HTTP-based messages, which means that it's much more efficient than TCP. Does it make sense? So with UDP alone, yeah, we will lose the quality of the content, right? But it's not UDP alone. HTTP3 uses UDP, but also it has its own algorithm on top of UDP.
Okay. Yeah, no, that makes sense. I can imagine with TCP there was sort of like old spec and baggage you had to deal with, and this.
Something like that, yeah, it has to do with that.
layer on
Yeah,
top,
yeah,
it works so much
yeah,
faster.
something like that.
That makes sense.
Okay, use Subfly. What's Subfly? It can save you data over gzip. Remember that we mentioned that we can use gzip? Well, Subfly, it's a new algorithm. It's recent over gzip. Okay, so it's still using the same zip algorithm, same container, but it's using a different algorithm to compress the data. The problem is that 80 times slower for compression, not for decompression. So it's more time on your server, not on users' devices, which is not so bad. Okay. Anyway, I will go really quickly over this because there is a better one. Broadly. Broadly is a completely new encoding format that replaces completely gzip, and it can save on text-based files up to 50% of data. So if you compress with Broadly, the amount of data that you are sending is 20% smaller. And if that happens, the file will be on users' browsers before, and it will help everyone. Today, Broadly is compatible with every browser. But anyway, if a browser is not supporting it, the server typically checks the encoding header, and if it works, it will return Broadly. I'm not sure if you remember that before I checked into the headers here, and there was one header, request header, that says accept encoding, gzip, deflate, and BR. BR is Broadly. In this case, the browser was telling the server, hey server, I accept Broadly. Okay, so then the server can decide to return a Broadly-based file. Broadly has the disadvantage of consuming more CPU as well. So most of the time, you want to cache it. That's done by the server. The server typically caches the Broadly file of a resource. So it's not compressing the file on every request. Okay? And LinkedIn has saved 4% in load time. Facebook, savings on CSS and JavaScript files. And yeah, that's a lot because we know that those resources are also the ones that are blocking rendering or blocking parsing. So we want to get them as soon as possible on users' browsers. So just check that you have that enabled. Again, if you are setting up your own web server, it's something you need to add. It's a module on Apache. It's something you need to enable on IIS if you're on the Microsoft side. And if you're using the cloud, typically it's a setting that you have to enable, and sometimes it's already enabled if you're starting now setting up those things. Okay? So have in mind that now we can serve content using Broadly. So before the next break, hacking resource loading. So now let's say that the LCP is already there as soon as possible. We have already hacked a little bit our code to make our largest contentful content as soon as possible. What about the rest of the content? Well, first, we should use modern image formats, not just PNG or JPEG. SVG can be one, but also we have WebP, ABIF or ABIF, Getsley JPEG, Subfly PNG. Okay, let's go one by one. WebP is currently available. It's called WebP. It's currently available in every browser, including Safari. Okay, it's much better than JPEG and PNG. It can replace both. It was created by Google. It's open source. ABIF, it's like WebP 2.0, kind of, and today it's only available on Chrome and Safari, but only on the Mac, not on iOS. There is a mix there. Okay. So Gessley JPEG, by the way, Gessley, Softly, Brotli, all these are German names used by Google to define these compression algorithms. That's why it's so complicated if you are not a German speaker. Okay? Gessley, Floply. Gessley JPEG, it's a new compression algorithm for JPEG files that is using the same JPEG format. That means that it can be rendered on IE6. It's not a special format that needs a special browser. It's just a different way to encode the file. And something similar happens with Softly PNG. It can like compress PNGs, normal standard PNG that works everywhere, even more. But ABIF and WebP are completely different formats, different containers. So you need a browser compatible with those formats. Okay. How to deal with these image formats? Oh, by the way, before doing that, if you're doing GIFs or GIFs, it's a very bad idea on your website because it's that format comes from 1989. It's actually really bad for performance. It's not optimized. You can use animated PNGs, animated WebPs, but the compatibility is kind of weird. And it's much better to use a mute video. You can do an MP4 mute. There is a Boolean attribute mute that works everywhere, and it's much better. Sorry. How to work with, there are many tools to work with images, but I encourage you to try Scoosh. Scoosh is a progressive web app created by the Chrome team. It's open source, and it lets you convert images. You can do it manually, like what I'm doing right now. I will do right now. By the way, it's 100% PWA client side. I can install it and use it as a Mac application or a Windows application. It's a PWA. And it's 100% client side, which means that your images are not being sent to the server. Everything is converted client side with WebAssembly. So I can drag and drop one image. For example, I can take my LCP image. That is the one that I wanna compress first. And I'm going to take my Asian grease and paste it here. No, it doesn't work. From BS, maybe not. Hello. Oops. Let's try again. Let's look for the file. It's in public, in gallery, ancient Greece. There we are. And here we can see the difference when we are changing formats. So this is if we want JPEG, ABIF, okay, or WebP. So here you can see the original and how the new one looks like. If you don't like it, well, you play with the quality, or if you want lossless, you don't lose any details. And here you can see how much space you will save. So the same file, in this case, I'm not even losing quality, and it's saving already 40% of the size. So then you save it, and I'm going to save this on the same file, public images, but no, images no. In gallery, Asian Greece, .webp. The problem is, what should we do with the WebP? Should I change this to WebP? I can. But what if we still have some users browsing with an old browser? Well, instead of doing this, what I can do is I can keep my PNG there and use Picture. Have you used Picture for responsive images? With Picture, you need to put the IMG, and what you're going to set is alternative sources for that picture. And I can set one for the type. So if it supports image WebP, I'm going to set the source as gallery Asian Greece WebP. And I can have also the ABIF version and many versions, and even one version using media queries, one version for mobile, one version for desktop. And when doing this, the browser will pick the right one. Does it make sense? And also, I should add the fetch priority as high. Fetch priority there, because it's our LCP image, right? We want high priority. But now, if the browser is WebP compatible, it's going to take that one. That is 40% smaller, so it will appear faster. We are saving milliseconds. Remember, we want to save milliseconds. Does it make sense? Scoosh, remember, it's a free app. You can use it as scoosh.app, scoosh.app. But also it has a version that is a CLI. If you search for a Scoosh CLI, it's on NPM. You can request conversions directly from the command line. So you can even make a little script that will do that for you on every image. Convert it into WebP, resize it in different formats. So you have a nice tool, also open source, to help with batch conversion. Does it make sense? Yep. So you can see that we are applying a lot of techniques at the same time, but each technique is saving a little more, a little more, a little more, until we get into our budget. Okay, makes sense? Well, more things that we can do. Do you remember from 2 hours ago that we were mentioning the conditional request? That when you have an asset, a resource in the cache, but it's expired, so then the browser needs to make a conditional request to the server. Well, on some assets, we know that that will never happen. For example, when you're using React or Angular or Vue CLI, all the assets that you get, the JavaScript, the CSS, they have a hash name. So the name is hashed. We have something like app05d.js. So we know that those files will never change. So a conditional request on those assets will always return, go ahead, the one you have is still valid, because those assets will never expire. Does it make sense? When you know that the asset will never expire, we can use cache control immutable. It's an HTTP header that you set on those assets. And for that, you say in the browser, sorry, let me take some water. And for that, we are saying to the browser, you know what, browser, this asset will never expire. So you don't need to make a conditional request, ever. Okay, makes sense? Another cache control that we have today is a new pattern that for those of you with experience with Service Worker, you have been already implementing it, that you need a file, you need a logo. Okay, if it's in the cache, here you have the logo. So I'm serving the logo from the cache. Okay, makes sense? For that, that's simple. But also, in the background, as a completely separate thread and process, I will go to the server and download the logo again and save it in the cache. I'm not updating it for you, for this navigation. It's for the next one. Does it make sense? That has a name. It's called stale war validate. And now it's also available on some browsers directly for the browser's cache. So you can express that for that image, you want to use stale war validate, and with the time that you want that for, can be minutes, hours, days. So you want that behavior. You always serve from the cache, but also you are updating that in the background for the next time I need it. It's just a cache policy over the browser. Okay? Now I'm going to mention something that was asked on the chat, warming up the engines. Sometimes it's a good idea to help the browser to start as soon as possible everything. But as we mentioned before, if everything is important, nothing is important. So I don't want to preload everything. But maybe I can do some things that can warm up some engines. Let's look into our app, into Frontend Museum. And let me show you something. Let me do a clean reload. So I'm going to disable Clash. That means that every time you reload, it starts from scratch. Let me see if we can find this. What I want to show you is that we do have fonts.google APIs that is coming from a different domain, fonts.googleapis.com, right? So I have my website is localhost, that's one host, and Google Font is coming from another file. So another server. And the same happens if you're using CDNs, or if you're using Google Analytics, or you are including a chat from a chat provider. So you're including scripts, files, resources from third-party domains. But you don't want to preload all of them, because again, we cannot preload everything. But something that we can do is we can warm up the engine to help with the DNS query and with the TCP and TLS connection. So, okay, don't download the file, but at least go and grab the DNS query, the IP address from that other domain, before you know that you will need it. Or go and open a TCP connection and start the SSL private key, public key negotiation. And for that, we can use DNS prefetch, that it looks similar to preload, but in this case it's not preloading a file. It's just getting the DNS. We are letting the browser know that it will need to know the IP address of that domain. Also, we can pre-connect. In this case, we're asking the browser, hey, why don't you go and start opening the connection? Because I know that you will need something from there. The browser doesn't know what to download yet, what to request toward that connection, but it will start making the call. Does it make sense? So that's why you can start doing that with a link element, also as an HTTP response, and we can use this with early hints. Remember early hints? The ones that while the server is working, we already sent some hints earlier to the browser. Well, we can send, hey, open a connection to that, start the DNS with that while I'm working on the server, or giving you the HTML. So in our case, in our project, something that we can do is, with the only external file that we have is fonts.googleapis, also fonts.geostatic.com. So we can add the link rel, and it can be DNS prefetch or pre-connect. It's up to you. What do you want to do? And you just pre-connect to that domain. In fact, in a modern Google font, you will get that by default. 2-3 years ago, it wasn't available. Google Fonts, I'm using the font Inter. So you go to Google Fonts, you search for that font Inter, this one, and here it says how to copy and paste the code. And you will see, let me copy that now. If you paste the one you have, it's already pre-connecting to both domains. Can you see that? Those two pre-connects? But if you were copying the code a few years ago and you still have your website up and running, you don't have those pre-connects. So now Google is suggesting me to add the pre-connect to both domains. Does it make sense? Not preload, pre-connect.
Yeah, so so how does this differ from preload?
That preload will also go and fetch the file.
So why would you not just do preload instead of pre-connect?
You can. The problem is that sometimes you have a lot of third-party domains. And maybe some of those domains are not so important for preload, for competing on the preload stuff, because pre-connecting and DNS prefetching is not competing with preload because it's not competing with the priority list or with the discovery list. It's just something on the network layer. It's opening some things. So you can do that in parallel without affecting the discovery queue and the priorities that you are downloading. Does it make sense? So it's like a different process.
Yeah, it's sort of like.
But if you need something to be preloaded, then you don't need to pre-connect or DNS prefetch because preload will do all the stuff as well.
Do it anyway, but if you pre-connect to the URL and then you preload one image, the preload is fine, but then it might mean that.
In fact, maybe you're right. In our case, I shouldn't be doing this for geostatic.com because we're already preloading a resource from it. So I can just keep fonts.google APIs.
But if you were loading from gstatic.com something else that you didn't preload, that would also load a little quicker because
the connection is already there. And the connection is not lost immediately after one, because this is HTTP2, the connection keeps connected for a while to see if you're still downloading or if more stuff. So it will wait 1, 2, 3 seconds before actually cutting the connection.
Yeah, you sort of have to know what you're doing.
Yeah.
While using
But if you don't know what you're doing, at least you know where to look for it. And that's the browser, the DevTools, the waterfall chart. You can use web page test to analyze what's going on. And then you know, oh, maybe this is because the thing is that sometimes you don't assume. Sometimes it's better to go test this, see it on the waterfall chart, and see what's going on.
Yeah, because weird things could be going on specific to your site.
Yeah, exactly. Okay, time for a break. Let's make a 10 minutes break.
Yeah, actually, right before we go, did you flip it yet? No. I say, can I just ask one more question that's
Okay, yeah, I can go do that.
related to here, just so we get in there?
The way now? Yeah.
Yeah.
Okay, yeah.
In this particular example, do you need to do a pre-connect to a domain when the next line is accessing the resource on that domain?
No, in that case, as I said, for this particular example, because I already have, well, let's say, if the next line is preload, the answer is no. If the next line is this one, the style sheet, the answer is yes. Why? Because having the link, this has to do with discovery, right? So, yeah, the browser will know that it has that file, but that doesn't mean that it will download that file now. And pre-connect will say, hey, open the connection now. Because when the browser will download the file will depend on the priority of that site. In fact, I think that the answer Google has an answer for you even without explaining you this. But they are giving you a suggestion of adding the pre-connect even if the next line is downloading the file. So Google is saying, yeah, you need the pre-connect because maybe the browser will download that CSS in 100 milliseconds, in 150 milliseconds, not now. The browser will discover the file, but the browser is not downloading all the files immediately after discovering them. It can wait. Pre-connect will start that, will warm up the engine immediately. Okay?
Cool.
Okay.
Now we'll
Break. 10 minutes break.